Good morning, everyone. Good morning, all.
Good morning, sir.
Am I audible clearly? Is there any
Yes,
background
sir.
noise? Thank you. So, welcome all. In the last lecture, we have discussed the syllabus structure, examination pattern, and we have taken small prerequisite test. So, all the prerequisites we require throughout the course, we have taken as a test. So, let's start with the first unit. I hope the screen is visible to all. Is the screen visible?
Yes, sir.
Yes, sir.
Okay, thank you. So, let us start with the first unit, linear differential equation. Linear differential equation. So you must have discussed already. I have discussed and solved the examples on linear differential equation in M2, but there you have solved the examples on linear differential equation of first order first degree, and even along with this linear differential equation, you must have solved the several types of differential equation there, like the equation which are solvable using the variable separable form or reducible to variable separable form, then homogeneous equations, non-homogeneous equations, right? Exact, non-exact, isn't it? So these are all the linear differential, these are all the types of differential equations we have discussed there. And along with this, you must have discussed the solution and formation of differential equation, right? With the order and degree of differential equation. So already we know that the order of the differential equation is what? The number of derivatives, highest number of derivatives throughout the differential equation, isn't it? So highest number of differential term gives the order of the differential equation, and the degree is related to the highest order derivative. So the degree is the exponent of the highest order differential term, right? So, if we have given a relation between the variables, then we know how do we obtain, how do we form a differential equation from that relation. What we do there, we just eliminate the arbitrary constants involved in the equation, isn't it? Suppose if we have given the relation um, y is equal to, say, a e to the power x plus b e to the power minus x, then we can form the differential equation associated with this. We just have to eliminate these arbitrary constants. Yes or no? We know how to form a differential equation. So the number of arbitrary constants involved in the relation is nothing but the order of the differential equations, right? So let us start with, in particular, now the linear differential equation with constant coefficient here. Linear differential equation with constant coefficient. LD with constant coefficient. Okay. So as we all know that the equation is nothing but the relation in variable equated to something, either maybe constant or the function, right? And the differential equation means what? Instead of variable, we are having the differential coefficients there. Instead of such functions, we'll be having the differential coefficients. So that becomes a differential equation. So mainly there are two types of differential equation, uh, or there are two types of derivatives: ordinary derivative and partial derivative, isn't it? And based on the derivatives, we have the differential equation. Like if we have the ordinary derivatives involved, then that equation is called ordinary differential equation. If the partial derivatives involved in the equation, then it is called partial differential equation. Is it clear to everyone? Then linearity. What is meant by linear differential equation? So a differential equation in which the degree is 1, isn't it? And there should not be a product of dependent variable and its derivative involved. So let us start with the relation first of all. If we have y as a function of x, then we call this y as a dependent variable, right? And x as a independent variable. So we all know that the derivative of this dependent with respect to independent is called, or it is denoted by dy by dx. So if we have only one such independent variable involved, then its derivative is called the ordinary derivative. Ordinary derivative. But if we have the function like this, y as a or z as a function of two variable x and y, suppose, then here we have the two independent variables, isn't it? Two independent variables. So, and this is dependent. Z is dependent. So, the derivative of Z with respect to X and Y are called partial derivatives, isn't it? And we denote them by dabba Z by dabba X and dabba Z by dabba Y, isn't it? So, this is called partial derivative. Partial derivative. So, always remember the dependent. How do we recognize which is dependent and which is independent? If the differential term is there, then जिसका derivative होता है that is dependent, and with respect to what, that is independent. Clear to everyone? Is this clear?
Yes, sir.
So we are going to solve such derivatives, differential equations. So you should know the solution of differential equation is the value of dependent variable in terms of this independent variable. So when we solve such derivatives, we will get a relation like this. Y will be, that is dependent variable will be a function of independent variable. So this will be the solution. Always remember. So if anybody asks you the solution of given differential equation, then you should know that solution is nothing but the value of dependent variable involved in the equation in terms of independent variable. Right? So let us start with the definition of linear differential equation. That is the standard definition. LDE with constant coefficient. So let me write the definition first. So before start with the definition, why these differential equations are introduced in our syllabus, that is the introductory part, let me tell you. Differential equations are widely used in the fields of engineering and applied sciences, right? So mathematical formulations of most of the physical problems are in the forms of differential equations. Use of differential equation is most prominent in subjects like circuit analysis, theory of structures, vibrations, heat transfers, fluid mechanics, etc. Differential equations are of two types. Just now we have seen, that is ordinary and partial differential equations, right? So in what follows, we shall discuss ordinary and partial differential equations, which are of common occurrences in engineering fields. So mainly the partial differential equations are used in mechanical fields, and these ordinary differential equations are used in the software fields, computer or ENTC field. Okay. So the definition of nth order LDE with constant coefficient. So, a differential equation which contains, we are defining now the definition of linear differential equation of nth order. So, a differential equation which contains the differential coefficients and the dependent variable in first degree and does not involve the product of a derivative with another derivative. Product of that should not involve the product of derivative with another derivative or with the dependent variable. And in which the coefficients are constants. The coefficients are constant. That is called LDE, linear differential equation with constant coefficient. Okay, so this is the definition of linear differential equation of nth order, a differential equation which contains the differential coefficients, right, and the dependent variable in first degree. This is very important condition. The differential coefficients and the dependent variable must be in first degree. Okay, and it does not involve the product of derivative with another derivative or with the dependent variable, and in which the coefficients are constant, is called LDE with constant coefficient. Clear to everyone? Everyone knows the degree of the differential equation, which is the exponent of the derivative, and that degree must be 1 only. Is it clear? So for example, let me write first of all the standard form of the differential equation. That mathematically, how do I write the differential equation with nth order? That is a naught d raised to n y by dx raised to n plus a1 d to the power n minus 1 y by d to the dx raised to n minus 1 plus and so on a n minus 1 dy by dx plus a n y is equal to the function of x on the right hand side, where these a naught, a1, and so on, a n minus 1, a n are all constants. Okay, so this is the standard form of nth order linear differential equation. For example, for example, first, um, say d2 y by dx square minus 5 dy by dx plus 6y is equal to say e to the power x. Okay? So this is a linear differential equation. You can see the order of differential equation is 2 because the second order differential term is there. Okay? So order of differential equation is 2, and if we check its exponent, that is 1 only, isn't it? 1. So it is linear, and you can see, you can observe there is not a product of dependent variable and its derivatives anywhere, and there is no product of the two derivatives also. So this is a linear differential equation with constant coefficient. Clear to everyone? Second example, let me write the second example. uh, that is say d 4 d cube y by dx cube plus say 2 d 2y by dx square plus 3 say y dy by dx plus 4y is equal to say sine x. So is it linear differential equation? Is it LDE with constant coefficient? Everyone, everyone should reply in chat box. Is it
Yes,
linear?
sir. Yes, sir.
Okay, Atharva says yes, it is linear. Sahil says it is linear. What about others? It is linear, linear, linear. Okay. Can you observe carefully what the definition says? Says there should not be a product of
Product of
dependent variable and its derivative. Right? So here we have y and dy by dx in multiples. So this is not a linear differential equation, though the coefficients are constants, but there is a product of dependent variable and its derivative. Clear? Clear to everyone? Atharv, then
Yes, sir.
these Prerna, Atharv, Dheeraj, Sahil.
Yes, sir.
Hmm?
Got it.
Yeah. So such questions will be there in competitive examinations to recognize whether it is LDE or not. So we should know LDE may first of all the degree must be 1. Then second condition is there should not be a product of derivative with another derivative, and there should not be product of derivative with the dependent variable. Clear? If the equation satisfy these three conditions, then that will be a linear equation, linear differential equation. So we are going to discuss the solutions of linear differential equation throughout the unit. I hope the point is clear to everyone. So let us start with the method of solution. Any doubt? Any question up to this in the definition of LDE? Any questions? Hmm?
no, sir.
Okay. So let us start with the methods of solution. So let me tell you first of all that what we are going to do exactly throughout the unit. See, we just now have discussed the definition of linear differential equation, right? So throughout the unit, the main theme is the solution of linear differential equation with constant coefficient. So there are mainly two types actually: LDE with constant coefficient and LDE with variable coefficient. Okay. So as I said, the main thing is throughout the unit, the main theme is to solve the LD with constant coefficient. Then what about LD with variable coefficient? Then what we are going to do, if the given equation is with variable coefficient, then with the help of suitable substitutions, we will reduce into LD with constant coefficient, and then we apply the methods of solution of LD with constant coefficient. Clear to everyone? So if the equation is linear differential equation with variable coefficient, then we first convert reduced into linear differential equation with constant coefficient, and then we do apply the methods of solution of LD with constant coefficient. Right? Is it clear? Hello. Is it
Yes, sir.
clear? So so the method of solution of LD with constant coefficient we are discussing. Solution of LDE with constant coefficient. Okay. So let us start with the equation again, which we have written earlier, that the standard nth order linear differential equation is, what is the standard form of nth order linear differential equation? It is a naught nth order derivative of y with respect to x plus a1 n minus 1th order derivative of y with respect to x plus, and so on, a n minus 1 first order derivative of y with respect to x plus a n y is equal to function of x. So first of all, tell me what is dependent variable and what is independent variable here. Hmm? Where of course these a naught, a1, and so on, a n minus 1, a n are constants. Okay. So my question is, what is dependent variable and what is independent variable involved in this equation?
X is independent.
Exactly. X is independent variable and y is dependent variable. जिसका डेरिवेटिव होता है वो होता है डिपेंडेंट, एंड विथ रिस्पेक्ट टू व्हाट, that is independent. I hope the point is clear to everyone. Why I'm asking repeatedly this? Because that is the only thing important throughout the unit. Because students, whatever the equation given, students are used to start with the standard different dependent variable as a y and standard independent variable as a x. No, okay. The given equation can be involved the x as a dependent and other t as a independent variable or something other variable. So you should know the value of the solution of equation, differential equation, is the value of dependent variable involved in the equation. Very good, Sahil. So this is the standard form. The MCQ can be asked for 1 mark. If it is online examination, then MCQ can be asked for 1 mark on this, that the standard nth order linear differential equation is, and one of the option will be this. Okay. So the first step toward the solution is, first step, put, see, will be given such equations. Let me show you. We'll be given such equations like solve d 2y by dx square plus 5 dy by dx plus 3y is equal to, say, sine x. We'll be given such equations and will be asked to solve this. Okay. So the solution of this equation will be the value of dependent variable involved in the equation, that is y here, and that will be in terms of independent variable. Okay, that is a function of x. So this will be the solution. We call this solution as a general solution or the complete solution. So let me write here. So the first step towards the solution is put capital D operator, which is derivative with respect to independent variable in the equation given. So when we substitute this operator into the standard equation, what we get? We get a naught d to the power ny plus, because we are substituting for this, right? D by dx. Okay? This we are substituting, d by dx. So What we get then? A naught d raised to ny plus a1 d raised to n minus 1y plus a2 d raised to n minus 2y plus and so on a n minus 1 dy plus a n y is equal to function of x. Is this first step clear to everyone? Is this clear? Any doubt? Hello.
Yes, sir.
So if you have any simple doubt, you just raise your hand or you can unmute yourself to ask your doubts, please. Okay. But try to get clear your concepts. Very important. See, the number of examples, how many examples we are solving throughout the lecture is not important. How you understand, that is important. Okay. If you know the concept, you can solve any example. So this is the first step. So what we do, as we know, this D, capital D is the derivative operator. This is operator. Okay. So these are all the operators: nth order operator, n minus one order operator, n minus two order operator. This is first operator, first order operator. So what we do, we take this y outside from these operators. So I can write this as a naught d raised to n plus a1 d raised to n minus 1 plus a2 d raised to n minus 2 plus and so on a n minus 1 d plus a n the whole times y I can write is equal to the function of x, right? So if you look at this bracketed quantity, this is a polynomial in D. Yes or no? Do you know the polynomial? Is it a polynomial in D? क्या होता है polynomial? Polynomial ऐसा एक relation होता है जिसमें powers of variables are the positive integers. Yes or no? Hello? Hello? See, first of all, let me clear you all that the session must be interactive. अगर कोई एक पढ़ा रहा है और बाकी सब लोग सिर्फ सुन रहे हैं, then that will not be an interactive and an interesting session also. See, I'm explaining something, so I'm expecting from you also that you should reply wherever, whenever I'm asking. So hopefully you'll do the same. Will it be a polynomial?
Yes, sir.
Yes, sir.
That will be a polynomial in D. Okay. We can consider D as a variable here. So polynomial in a variable D. So let us denote that polynomial as a function of D. That is denoted by phi of D. The whole times y is equal to the function of x. So this is the reduced standard form of nth order linear differential equation. Reduced. Reduced standard linear differential equation of nth order. Okay? So we are going to solve this now. So as I said earlier that the solution of differential equation is nothing but the value of what? किसका value होता है solution means? Hmm? Solution of differential equation means
Dependent variable.
exactly we are finding the value of dependent variable. So here the dependent variable is y. So its solution is the solution is called general solution. Solution is called general solution or complete solution, and that is the value of dependent variable y as a function of independent variable, that is x here. So that solution will be of this form: y is equal to cf plus pi. Cf plus pi. This is the solution of linear differential equation. Now, what is this Cf and pi that we are going to discuss? But this is called a general solution or the complete solution. We'll be asked to find this solution for either 5 to 6 marks. So if the question is for 5 marks, then 1 mark for the complementary function CF, and 4 mark for the particular integral PI, or 2 mark for the complementary function and 3 marks for the particular integral. So depending upon the difficulty level of CF and PI, I will be having this as a marking scheme. Clear to everyone? Hmm? So let us start with one by one. Let us discuss about the complementary function and then particular integral. But is it clear to everyone? Any doubt? Any question up to this?
No, sir.
Okay, so let's start with the complementary function. The first solution. These are both of these are the solutions. We can say sub solutions. One is complementary function and the other is particular integral. Both are the sub solutions. So let us find these two sub solutions. Then their sum will be the required general solution or the complete solution. Isn't it? So let's start with the first as a complementary function. So to find the complementary function, what we do, we first consider, see what, first of all, let me write here, we are solving to solve for CF of phi of d into y is equal to f of x. We are trying to find the complementary function of this equation, right? Linear differential equation. So to solve this, we consider a homogeneous differential equation, that is phi of d into y is equal to 0. So this is called a homogeneous differential equation. So the MCQ can be asked on this also if it is asked. The homogeneous differential equation for this linear differential equation is, so that we have to consider only the right hand side to be 0. So the solution of this homogeneous differential equation will be the complementary function, isn't it? So to solve this homogeneous differential equation, we consider its auxiliary equation. So its auxiliary equation is phi of d equal to 0. Phi of d equal to 0. That is, what is phi of d? Phi of d is a naught d raised to n plus a1 d raised to n minus 1 plus a2 d raised to n minus 2 plus and so on a n minus 1 d plus a n is equal to 0. Yes or no? Is it clear? यहाँ तक clear है सबको?
Yes, sir.
So if you look at this is a equation in variable d. This is an equation in variable d. And what is the degree of this equation? What is the degree of this equation? अगर कोई equation है मेरे पास, doesn't matter whether it is linear, quadratic, biquadratic, cubic, but
N.
that is an equation. So
And
here the degree of this equation is n. So if we ask to solve this equation, then how many roots we will get when we solve this equation?
N roots.
Exactly. So this is nth n degree equation having n roots, isn't it? So let us suppose those n roots are, so let m1 m2 and so on, mn are n roots. ठीक है, हम कंसिडर कर रहे हैं कि those n roots are m1 m2 mn. Then we all know that if we have roots, then we can have the factors. So what are the factors associated with these roots? Can you tell me the factors? Hmm? Then what are the factors? Can I say these are the factors d minus m1, d minus m2, and so on, d minus mn are factors. Can I write like this? Is
Yes,
it
sir.
correct? These are the factors. Because if we equate these factors to 0, then only we are getting these roots, na? m1, m2, mn. So I can write this phi of d into its factored form. How do I write? Phi of d I can write into its factored form, like, therefore phi of d is equal to 0, means d minus m1, d minus m2, and so on, d minus mn is equal to 0. Is it correct? Is it clear to everyone? Just like, suppose if you are not able to understand this, let me show you by example. If we have the equation like this, x square plus, say, 3x plus 2 equal to 0, what are the roots of this equation? Hmm? By splitting middle term method, we split the middle term 3x with the help of two numbers whose multiplication is 2, right? So I can write this as a x square plus 2x plus x plus 2 is equal to 0. Yes or no? So when I take x common, then I'll get x into x plus 2 plus 1 into x plus 2 is equal to 0. So what I'll get, x plus 2 into x plus 1 is equal to 0. So this is the factored form of this polynomial. Is it clear? That is what I'm trying to show here. Clear to everyone? So as
Yes.
m1, m2, mn are the roots, this is the factored form of that phi of d. And with this factored form, we are going to get our complementary function. So first of all, let me write the formula directly, and then let me explain why this is the formula for the complementary function. Okay. So with these roots m1, m2, mn, the complementary function is CF. Directly I'm writing the formula here. CF is equal to C1 e to the power m1x plus C2 e to the power m2x plus, and so on, Cn e to the power mnx. So this is the only formula we require for the complementary function. But now you must be thinking, why and how do we get this formula? Okay, so let us discuss the explanation here. So as we all know, this is the factored form of, yes, any doubt? Anybody want to ask any doubt? Someone has unmuted just now. No doubt? Okay,
No, sir.
all right. So as we all know, the factored form of phi of d, that is d minus m1, d minus m2, and so on, d minus mn equal to 0. So each root, like suppose m1 will satisfy this equation. Yes or no? m1 will satisfy this equation, or m2 will satisfy the equation, the whole equation, phi of d, or mn will satisfy the whole equation, this phi of d. So what I'll consider here, if I consider the LDE of first order first degree, see, we are discussing the explanation for this formula. Okay, so for the explanation purpose, let us start with the linear differential equation of first order first degree. So that will be something like this, na, phi of d into y is equal to 0. So its auxiliary equation is phi of d equal to 0. And how many roots it will have? How many roots this auxiliary equation will have? Only one root, na? As it is of first order, first degree. So it will have only one root. Yes or no? So I can write, suppose if m is the root, then yeah, if m is root, then I can write this phi of d into its factored form. How do I write? D minus m is equal to 0. Is it clear? Hello.
Yes, sir.
Yes, sir.
So if I substitute this phi of d here, then I can write this homogeneous differential equation as a d minus m times y is equal to 0. And if I resubstitute the value of d, and by taking y inside, I can write this as a dy by dx minus my is equal to 0. Is this step clear? Please do reply. ये जो मैंने लिखा है ये clear है सबको?
Yes, sir.
So
Yes, sir.
can we compare this with the standard form of linear differential equation? What is the standard form of LDE? Hmm? Of first order first degree. The standard form of linear differential equation of first order first degree is dy by dx plus p of x into y is equal to q of x. Yes or no? So if the given equation is into its standard form, then we can have its solution directly. What is the solution? Then its solution is, what is the solution? कोई बता सकता है? What is the solution of this LDE?
Y is equal to f of x.
No, no. You must have solved the solutions of such LDE of first order first degree in M2. So that is why I'm asking. Hmm? Just see here. Is it of this form that dependent variable into some integrating factor is equal to integration of the right hand side function into integrating factor plus constant? Is it right?
Yes, sir.
Yes, sir.
So if we compare this standard form with this, so what are the values of P and Q and I? What is P there? P is P of x is minus
M
m
minus M.
minus m. Q of x is 0. So with this P of x, what will be my integrating factor? I will be e to the power integration of P of x dx, isn't it? So that is e to the power integration of minus m dx. So what it will be? It will be e raised to minus mx. Clear to everyone?
Yes, sir.
So with this integrating factor, what would be my solution? Therefore, the solution is y into integrating factor, that is e to the power minus mx is equal to integration of q. You can see here the solution. Okay, integration of q. Q क्या है यहाँ? 0 into integrating factor plus constant of integration. So as the integration of 0 is 0, so what I can write? I can write this as a y e raised to minus mx is equal to c. यहाँ तक clear है सबको? So I'll divide this exponential term outside. What I'll get therefore? Y is equal to c e to the power mx. Yes or no?
Yes, sir.
ठीक है? So what I'm trying to show here, with respect to m root, we are getting its solution as a c e to the power mx. So, and we have seen from this equation, from this one, each root is satisfying this equation, right? Each root is satisfying this equation. That means corresponding to each root, we can have such solution. Such solution. Yes or no? Hello, corresponding to each root, can we have such solution?
Yes, sir.
Yes,
So
sir.
with respect to m1, I can get the solution like c1 e to the power m1x. With respect to m2, I can get the solution of the form C2 e to the power m2x, and so on. With respect to mn, I can get the solution of the form Cn e to the power mnx. Right? So let us denote these solutions as a y1, y2, yn. ठीक है? So there is one standard results in pure mathematics. अगर आपके पास y1, y2 and so on yn ये सब solution है, then their linear combination is also a solution. Then y1 plus y2 plus and so on yn is also a solution. Do you know this result? This is also a solution. So with this, what we can write? The solution is therefore y is equal to, ये किसका solution है? Homogeneous differential equation का. Therefore y is equal to y1 plus y2 plus and so on yn is a solution. So let us substitute the values of y1, y2, yn. That is c1 e to the power m1x plus c2 e to the power m2x plus and so on cn e to the power mnx. ठीक है? This is the solution of the homogeneous differential equation phi of d into y is equal to 0. इसका ये कॉम्प्लीमेंट व्हाट सॉल्यूशन है. सो अगर राइट हैंड साइड हमारा ऑलरेडी नॉन राइट हैंड साइड नॉन जीरो है तो इसी को बोलते हैं कॉम्प्लीमेंट्री फंक्शन. देयरफॉर cf is equal to c1 e to the power m1x plus c2 e to the power m2x plus and so on cn e to the power mnx is the required formula for the complementary function. I request everyone to raise your hands if any doubt. Any doubt, any question? देख लो एक बार इसको.
Sir, only if the right hand side is 0, na? Then only its solution.
No, actually, let me explain again. See, we are trying to solve this equation, right? Phi of d into y is equal to f of x, right? And it's as I said, its solution is y, which is a cf plus pi, right? Hello.
Yes. Yes,
Huh?
sir.
So to find CF, we are considering the right hand side to be 0 only. तो ये CF क्या है? इसका solution है 5 of d into y is equal to 0. इसका solution है. तो अगर आपको originally 0 दिया है ये, then CF is the only solution for that equation. But अगर ये non zero है ये वाला, then उसका CF भी होगा and PI भी होगा. Clear?
Okay, sir.
So to find complementary function, we have started with the right hand side to be 0 there. We have got now the complementary function. Then later we will consider the original equation and then we will find its particular integral. So the sum of those two will be the required complementary function. Clear now?
Yes, sir.
Okay. Anyone else? देख लो एक बार इसको, अगर कोई डाउट हो तो पूछ लो, बिकॉज दिस इज वेरी इंपॉर्टेंट. Any question? Any doubt? You please reply.
Sir,
हाँ, yes.
are they C1, C2, and
PIs are arbitrary constants. You can see here, this is arbitrary constant, right?
yes.
So these C1, C2, Cn are also arbitrary constants. And one more thing, जितने आपके पास रूट्स होंगे ना, उतने ही arbitrary constants आएंगे complementary function. उससे ज्यादा भी नहीं आएंगे, कम भी नहीं आएंगे. So that is the one way to cross verify whether we are writing correctly our complementary function or not. Clear? Who's that? कौन पूछ रहा था? साहिल?
Yes, sir. Yes, sir.
Okay, okay. Is it clear now, Sahil?
Yes.
Anyone else? I request everyone to reply in chat box. Clear or any doubt? Everyone. Very good.